Okay, think about this for a second. Your body, right now, it's like this incredibly busy factory.
Mhm.
But instead of machines, it's run by these tiny chemical signals.
Mhm.
Messengers, really.
Constantly sending out instructions.
Exactly. We're talking about hormones. They're kind of the hidden conductors, aren't they? Running everything from, how energetic you feel, your mood, even growth, sleep.
Pretty much everything vital, yeah.
So today, we're doing a deep dive into a source. It's a really comprehensive article that unpacks these chemical messengers.
Laying out the fundamentals.
Right. And our goal isn't just to, read a definition. We want to really get into this source material, understand what hormones are, how they actually work, where they're made, and there's some surprising places.
Definitely some surprises there.
And critically, why keeping them in balance is just so essential for your health. Think of this as, a shortcut to understanding this core system that affects almost every single part of you.
It's a system that, often works silently in the background. It's easy not to notice it.
Until it's not working right, maybe?
Exactly. But as the source highlights, its influence is just massive. It covers such a huge range of what our bodies do.
Okay, let's get into it then. The source starts simple. Hormones are chemical messengers. Sounds straightforward, but what does that really mean, functionally?
Well, it means they're the body's main way of coordinating things, especially complex processes across different parts of the body.
So long-distance communication.
Pretty much, yeah. They mate in one spot, then travel mostly through the bloodstream to reach target tissues. That could be organs, skin, muscles, you name it.
And they carry instructions.
Specific instructions, telling those targets what to do and, importantly, when to do it.
So they're not just drifting around randomly, they have a destination and a purpose.
Precisely. And the source really hammers this home. This communication is absolutely fundamental, essential for life and health. It's not optional.
Okay. And when we say chemical messengers, we're talking just a handful. The big ones everyone knows, insulin, maybe adrenaline.
Oh, way more than that. The article mentions scientists have identified over 50 hormones so far in humans, and probably more to come.
Wow, okay, 50. And what about the range of jobs they do? What is the source list?
It's huge. The source points to things like metabolism, basically how your body uses energy.
Right.
Hugely important for homeostasis. That's keeping everything stable inside,
Like temperature, blood pressure?
Exactly. Blood pressure, blood sugar levels, fluid balance, body temp, all that needs constant adjustment. Hormones manage that.
Okay, what else?
They also drive growth and development, obviously. Sexual function and reproduction are heavily hormone dependent. Your sleep-wake cycle, that's hormones too.
Melatonin.
Melatonin's a key one there, yeah. And even mood. Hormones have a really significant impact on how we feel.
It's just amazing that these, relatively simple chemicals can have such broad critical roles. The article uses a phrase, a little bit goes a long way. That really jumped out at me.
That's absolutely key. It means they're incredibly potent. So even tiny changes, a little too much or a little too little, can cause really significant problems across the body.
Which explains why hormone imbalances can lead to health conditions.
Exactly. Their power means that balance is critical. It's a very finely tuned system.
So, if they're traveling everywhere in the blood, how do they know where to deliver the message? Why doesn't, say, insulin start telling your eye cells what to do?
That's the elegant part. The source explains it using the lock and key analogy, which works really well.
Okay.
Think of the hormone as the key. It circulates everywhere, but it can only unlock a response in a cell if that cell has the right receptor, the specific lock for that key.
So the cell needs the matching receptor protein.
Precisely. If the key fits the lock, the cell gets the message and acts on it. If not, the hormone just passes by. No effect.
Got it. The right key for the right lock. Makes sense. The source also mentioned different types of hormonal communication, didn't it? Beyond just a gland talking to a target cell.
Yes, it outlined two main patterns. One is communication between endocrine glands themselves.
Gland-to-gland talk.
Right. So one gland releases a hormone whose job is specifically to signal another gland. It might tell that second gland to make more of its hormone or maybe less.
Like a control train.
Exactly. The article gives the example of the pituitary gland releasing TSH, thyroid-stimulating hormone.
Okay.
TSH travels to the thyroid gland and tells it to produce its thyroid hormones. It's hierarchical.
And the second type of communication.
That's more direct. It's when an endocrine gland releases a hormone that acts directly on a target organ that isn't another endocrine gland.
Oh, okay.
The source uses the pancreas releasing insulin as the example here. Insulin travels to muscle cells and liver cells, telling them directly to take up glucose from the blood.
So command and direct action, rather than passing the message along a chain.
You got it. Different relationships for different needs.
Okay, so we've got the what chemical messengers and the how lock and key specific communication pathways. Let's talk where. Where are these hormones actually made? The source calls these places the factories of the body.
Right. The main production sites, the ones we usually think of, are the endocrine glands. These are specialized organs basically built for making and releasing hormones straight into the bloodstream. That's the classic endocrine system the source details.
And the article walks us through the major players kind of top down.
Yeah, it starts in the brain. You've got the hypothalamus. It's technically part of the brain, but it's a crucial link between the nervous system and the endocrine system. It exerts a lot of control, especially over the pituitary gland.
The master gland, they sometimes call it.
That's the one, yeah. The source mentions that nickname. It's tiny, like pea-sized, at the base of the brain, but it makes hormones that control many other glands, things like growth hormone, TSH, like we mentioned, ACTH, which affects the adrenals, others involved in reproduction like FSH and LH. Lots going on there.
Still in the brain.
Also the pineal gland, even tinier. Its main job is making melatonin, which, as we said, is key for regulating sleep-wake cycles, our circadian rhythm.
Wait, moving down from the brain.
Then you get to the thyroid gland in the neck. It's sort of butterfly-shaped.
Right.
It makes T3 and T4, the main hormones controlling your overall metabolic rate. And tucked just behind it, usually, are 4 tiny parathyroid glands. Their hormone, PTH, is all about keeping calcium levels in your blood balanced. Super important.
Okay, what's next?
Sitting on top of each kidney, you have the adrenal glands. These are complex little guys. They make stress hormones like cortisol and adrenaline, but also other hormones involved in blood pressure and electrolyte balance.
And then there are organs we know for other jobs, but they're also hormone factories.
Exactly. The pancreas, for instance, we think of it for digestion, making enzymes, but it also has these clusters of cells, the islets, that make insulin and glucagon, absolutely vital for blood sugar control.
And the gonads.
And the gonads, yes. The ovaries in women producing estrogen and progesterone, and also a bit of testosterone. And the testes in men making sperm, but also the primary source of testosterone. These are the core endocrine glands the source lays out.
Okay, but here's where, for me at least, the source got really interesting. It makes this point that kind of broadens the picture quite a bit.
Ah, you mean the part about hormone producers that aren't technically part of the endocrine system?
Exactly. It says not all tissues making hormones are considered endocrine glands in the traditional sense.
Yeah, that's a fantastic point in the source. It really shows how integrated everything is. It's not just these dedicated glands. Other tissues are in on the act, sending out crucial chemical signals.
Like, I was genuinely surprised by the first one listed. Adipose tissue. Fat tissue.
Right. It's not just inert storage. The source points out fat tissue makes hormones like leptin, which is involved in appetite regulation, and it even produces some estrogen.
So fat is metabolically active and communicating. That changes how you think about it.
Totally. And the kidneys, too. We know they filter waste, but the source notes they produce erythropoietin EPO, which tells your bone marrow to make more red blood cells.
Wow, right?
They also make renin, involved in blood pressure. And here's a cool detail from the source. They activate vitamin D. It points out vitamin D isn't just a vitamin, it starts as a prohormone, and the kidneys turn it into the active hormone form.
That's a great clarification. Vitamin D is a hormone, essentially. What else?
The liver is on the list, does tons of metabolic stuff, right? But it also produces things like IGF-1, insulin like growth factor 1, and angiotensinogen, another player in blood pressure regulation.
And the gut, the digestive tract.
Oh yeah, the gut is a huge endocrine organ, in effect. The source mentions scientists are really digging into all the hormones made there. Ghrelin, the hunger hormone, somatostatin, GLP-1. These affect digestion, appetite, insulin release, maybe even mood. It's a hot area of research.
Fascinating. And one more the source mentions, though it's temporary.
Right, the placenta during pregnancy. It's a temporary organ, but it churns out massive amounts of estrogen and progesterone, absolutely essential to maintain the pregnancy.
So pulling back, it's not just these distinct glands. Hormonal signaling is woven through tissues we think of for totally different jobs: fat, kidneys, liver, gut, even the placenta.
Exactly. It highlights this distributed network of chemical communication. It's much more complex and interconnected than just the classic endocrine system diagram.
Okay, so we've established they're powerful, they work via lock and key, they come from glands and other tissues. What does this all mean when things go wrong? Given how potent they are, that little bit goes a long way thing. What happens when the balance gets thrown off?
Well, as the source makes very clear, that's when problems start. If your body makes too much of a hormone overproduction or too little underproduction, that imbalance can lead to a whole host of health conditions.
And the article lists some common examples, right? Things people might have heard of.
Definitely. It mentions diabetes, obviously type 1, type 2, gestational diabetes during pregnancy, all related to problems with insulin, the hormone from the pancreas.
Who makes sense?
Thyroid disease is another big one. Hypothyroidism, where the thyroid makes too little hormone, leading to sluggishness, weight gain.
Yeah.
Or hyperthyroidism, too much hormone, causing anxiety, weight loss, rapid heartbeat.
Okay.
For women, the source links hormone imbalances to irregular periods, conditions like PCOS, polycystic ovary syndrome, amenorrhea, which is the absence of periods, or anovulation, not ovulating.
And it impacts fertility for both men and women.
Yes. The source lists female infertility and also male infertility, specifically mentioning low testosterone or hypogonadism as a factor there.
And obesity is on the list too.
It is. It's complex, obviously, but the source notes obesity can be linked to or certainly influenced by hormonal imbalances, especially thinking about those hormones made by fat tissue itself, like leptin.
Right, that connection we just talked about. Does the source give any general reasons why these imbalances might happen in the first place?
It mentions a few main categories of causes. Things like tumors or growths, usually benign adenomas, on an endocrine gland can mess up its production either too much or too little.
Okay.
Physical damage or injury to a gland can impair it. Autoimmune conditions are a really common cause too, where the body's own immune system mistakenly attacks an endocrine gland, like in Hashimoto's thyroiditis or type 1 diabetes.
Ah, the immune system turning on itself.
Exactly. And finally, the source mentions hereditary factors, gene mutations that someone inherits, which can affect how these glands develop or function right from the start.
So, quite a range of potential causes. It definitely sounds complex, but presumably, this is something doctors can diagnose and treat.
Oh, absolutely. And the source emphasizes, quite rightly, that if you're having symptoms that worry you, things that might suggest a hormone issue, the essential first step is always talking to your healthcare provider. Don't ignore it.
Your regular doctor.
Your primary care provider can often manage many common hormone issues, yeah. But the source specifies that the real specialist in this area is an endocrinologist. They're the doctors with deep training in the endocrine system. They can do the detailed testing needed for diagnosis, figure out the best treatment plan, prescribe medications if needed. They really manage the whole spectrum of hormone-related conditions.
Okay. Good to know who the specialists are.
So, kind of wrapping up this deep dive based on the source, it's just incredibly clear how vital hormones are, isn't it? These potent chemical messengers are orchestrating this vast, complex network of functions all through our bodies.
Yeah, and they don't just come from the classic glands we learned about in school. They're also produced, as the source surprisingly points out, in places like fat tissue, our kidneys, the liver, even our gut.
It really paints a picture of a much more integrated, distributed communication system than maybe we realized.
The sheer scale and interconnectedness of it all is what's really striking. It's happening constantly, mostly without us even noticing.
That constant adjustment.
So thinking about that phrase from the source again, that the body normally carefully balances its hormones. Just take a second and consider that. This incredibly delicate, nonstop balancing act going on inside you right now. Across all those different glands, all those other tissues we mentioned.
Billions of tiny signals, keeping everything running.
It's really a silent testament, isn't it, to how deeply integrated our bodies are, all coordinated by these tiny but incredibly powerful chemical signals. It just makes you appreciate the unbelievable complexity behind simply staying healthy and, keeping the whole factory running smoothly.